Okay, in this video we will talk about solving system of linear equations, and we also call it solving simultaneous equations. There are two ways to solve it: elimination method and the substitution method. Okay, a brief overview about what system of linear equation is and how its solution looks like on an xy plane. Okay, before I start off, I suppose that you know how to graph linear equation on an xy plane, and if you don't, I have a video on this topic and you can find its link in the description below. Okay, a system of linear equation can have a lot of lines, like 2, 3, 4, 5, a lot of lines. For now we will just be dealing with 2 lines, each linear equation having one of its line. Okay, suppose we have 2 equations, like 2 line equations, L1 and L2. In case 1, there we have a solution, like there is a point where these intersect. This intersection point is known as the solution of the linear solution of the system of linear equation, or the simultaneous equations. The solution of simultaneous equation. Okay, here they intersect at a point where x is equal to -1 and y is equal to 2, this point. Okay, let's move on to case 2. In case 2, these 2 lines are kind of parallel, and if they are parallel, they will just go on and on and on and on, and they will never meet each other and they will never intersect. And when you solve a system of such 2 equations, you will get like this type of answer. Like, it's not an equality, it does not make any sense, the answer does not make any sense. In case 3, the 2 equations, the line of these 2 equations overlap. Like, it looks like it's the same line, but these are equation of 2 lines which are overlapped. Okay, when you solve 2 such equations, you get an answer like this. There is no x, no y, just answer is like 8 is equal to 8. It makes sense, but it is like this. Okay, so let's move on and solve one of these examples using the elimination method. Okay, let's take our first example as x plus y is equal to 7 and x plus 2y is equal to 4. These 2 are separate linear equations, equation 1 and equation 2. These both are in the standard form, not in the slope-intercept form. In order to solve it, we have to get it in the standard form. Alright, so the first step in solving using the elimination method is we look for how can we cancel one of these variables, either x's or y's. How can we cancel these out? We can add or subtract. Over here we can cancel out this x if we minus equation 1 with equation 2. Alright, if we minus it, this becomes minus, this becomes plus, and this becomes minus. This becomes minus. The sign changes when you put a minus sign. Minus plus is minus, plus minus is again minus, and plus minus is again minus. So x minus x is 0, nothing, and y minus 2y is minus y, equal to sign, and then 7 minus 4 is 3. If we multiply with the minus sign, multiply both sides and -1 to get it positive, we get y is equal to -3. Okay, now we have our y, and to get our x, we can put this y is equal to 3 in the equation 1. We can put it in either equation, but we can see that this equation is a lot simpler to solve, so we'll go with this one. X minus 3, that is y, is equal to 7. Let's write it x plus -3. It will become x minus 3 is equal to 7, and then we add 3 on both sides. We get x is equal to 7 plus 3, x equals to 10. Okay, so here we have a solution where we have x value and a y value. So these lines kind of intersect somewhere, not somewhere, where x is equal to 10, x is equal to 10 is somewhere over here, and y is equal to minus 3 is somewhere over here. So they intersect over here. These are like this sort of line. They intersect at one point. This is our case 1. Okay, so one more thing I would like you all to know is that what if we have to cancel out this y first. Here we cancel out this x, and what if we have to cancel out this y? It's a difficult job, so we prefer to cancel out this x, but we can also do that. In that way, we have to do is we write this down: x plus y equals to 7. Like we separate it. This becomes equation x or y, anything. This is 7. Okay. So to cancel this y out, what do I have to do? I can do is multiply this whole equation with minus 2. So this becomes minus 2y, and then we add it. And when we add it, these both cancel out. Or we can just multiply it with 2. Multiply it with 2 and then minus this equation with this equation. Okay, let's multiply it with 2. It becomes x plus 2y is equal to 4. I copied this equation 2 over here. Let's make it equation 1. And when I multiply it with 2, I get 2x plus 2y equal to 7 times 2 is 14. Okay, so when I subtract this equation 1 from equation 2, x minus 2x becomes minus x, and then 2y minus 2y becomes 0, and then 4 minus 14 becomes 10. 4 minus 14 becomes minus 10. Okay, so minus cancel out, x is equal to 10. We get x is equal to 10, and then when we put x is equal to 10 when we put this in this equation back into this equation, it becomes 10 plus y is equal to 7. We subtract 10 on both sides, we get y is equal to 7 minus 10, and it becomes y is equal to minus 3. Here we get our answer again. We can multiply the whole equation with any constant, with any number. We can multiply any equation with any constant. It does not make any difference on the line. So here we have our case 1 equation. Case 1 solution, that is 10 comma minus 3. We represent the solution this way. Okay, let's move on to second example. Okay, here we have our second example using the elimination method. What can we eliminate first? Let's write it other way around. I'll just write this equation below it. Y minus 2x is equal to 4, and I'll just erase this one. This is 16. Alright, so as we did in the previous part, we can just multiply it with 2 and then subtract this equation 2 from equation 1. We can name it either one as equation 1, equation 2, it's up to us. So when I multiply equation 2 with 2, it becomes, first I'll copy this down, 2y minus 4x equals to 16, and then when I multiply 2 with this equation, I get 2y minus 2x equals to 8. And when I subtract it, this is minus gets plus. So when I do it, it becomes 2 minus 2, it cancels out, it becomes 0. Then 4 plus 2 minus 4 plus 2, it becomes minus 2x, and it becomes okay, when I multiplied it, I just did a mistake. It becomes 2 times 2 is 4. 4x minus 4x plus 4x becomes 0, and 16 minus 8 becomes 8. It becomes 8 equals to 0. This does not make any sense. 8 is not equals to 0. So this is our case 2. These lines are parallel and they do not intersect. How long they go, they just won't ever intersect. You can notice one thing from this equation, that is 2y minus 4x is equal to 16 and y minus 2x is equal to 4. Let's just remove it for now. You can notice one thing. If I divide this equation by 2, as I said in the previous example, it doesn't matter which constant we multiply our equation with. If we divide it by 2, it becomes y minus 2x is equal to 8, and this equation y minus 2x equals to 4. If we write this in the slope-intercept form, each equation becomes y equals to 2x plus 8, and this becomes y equals to 2x plus 4. They have the same gradient. So the equation having same gradient, same slope, or same gradient, they will always be parallel, and they won't have this x or y value. They won't have a specific x or y value. Okay, let's move on to our third example. Alright, here's a third example, and the first thing that we do is we write these in the standard form. Right now this is in the slope-intercept form, and this I don't know is which form. Actually, if we divide all the terms by 3, it will become a slope-intercept form, but for now we'll just bring that in the standard form, which is all the variables on the one side and the constant is on the other side. Let's do it. 3y is 24x. If we minus it on both sides, becomes minus 24x equals to 21, and if we write this too, becomes y minus 8x equals to 7. This is our equation 1. This is equation 2. Okay, when we solve it using the elimination method, we know that we will multiply it with 3 and then subtract it to eliminate this y. Okay, so let's multiply this equation with 3. I'll just write this first equation before anything. Alright, 3y minus 24x is equal to 21, and I'll multiply this with 3. It will become 3y. 8 times 3 is 24 minus 24 minus 24x. 7 times 3 is 21. Okay, when I minus it, this all cancels out. 3y minus 3y equals to 0. This also cancels out. It becomes 0, because if we, this becomes plus and this becomes minus. Minus 24x plus 24x becomes 0, and this 21 minus 21 is also 0. So we get 0 equals to 0. This is our case 3. That is when two lines overlap each other. Like these are both the same lines plotted on each other. They also have the same gradient. If you notice that if you divide this equation by 3, we get y equals y. If we divide this equation by 3, we get y equals to 3y divided by 3 becomes y equals 24 divided by 3 becomes 8x, and this becomes 21. It is 21 divided by 3 becomes 7. Okay, so this is same as this. These both equations are same. It's just a multiple of each other. So when we multiply any equation with a constant, it does not make any difference on that line. These both are the same line plotted on each other. So they both are same, and they have the same gradient, 8a. So you know when the lines are same, they either overlap or they run parallel. They overlap because we have the same 7 value. The whole equation is same, so they both overlap, and in this case it means that it has infinite solution. Infinite solution. It means that it has infinite points where these both lines intersect. There are infinite points. Alright, that's it for now. I hope you get all the cases and the elimination method, how we do it. In the next video we will be doing the substitution method. You can find its link in the description below. and I have the links of other videos in the description as well, so do check them out. Thanks for watching.